Hello everyone, today I'll be showing y'all how to download climate model projection data. So this data is to see how temperature is projected to increase in the coming decades due to climate change. And as always, there's a lot of different ways to do it, but the way I've learned to do it is to go to this website, ESGF. So it's saved in my search history, that's why it was right there, but I'll put a link to this website on the description box below so it's easy to find. And the first thing you're gonna have to do when you get to this website is to create an account. I already have one here, but it's pretty straightforward. You just have to follow the directions in the website and then you can make an account. And the data is free and open to everybody. You just have to when you're creating an account, you have to say what you're using this data for, and then you can have access to all this information. So the way I like to do it is to, once you're in this website, is click on this More Search Options link. If you know exactly what kind of climate projection data you're looking for. Otherwise, you can just explore here and see what kind of data they have. I haven't even done that. I just knew what I needed and then I went here looking for it. So how it works is here on the left, you have all these different search parameters and then you can narrow down the data to find exactly what you need. And the easiest way I found is to first choose the project you want to get the data from, and then as you choose different parameters, just keep clicking search so that your options are narrowed down so you don't have to scroll through all these different choices each time. So the most recent climate projection data from the IPCC is in this project called CMIP5. So just click on that and then click search. And as you can see, the list of products has been narrowed down. Next is, if you know what you want, you can just go here and click on all the different options. So time frequency and then the variable you're looking for and all that. I think it's good to next go on the variable because usually you know what kind of variable you're looking for is temperature data, precipitation data, and there's a ton of options here. And I don't even know what all of these are, but there is another box here with a long name of the variable, so you can see exactly what you want. But since I'll show you the data I got for my project because that's the one I'm most familiar with. So once you get to the T's is where you have your temperature data, and TAS is average air temperature, atmospheric temperature. So you can just click on that. I've been using maximum temperature, so that's what I'm gonna choose because I know what that's gonna look like. And then again, just keep clicking search every time you decided what kind of information you want because it really narrows down your options in the other boxes. And next is to choose the time frequency. So for that variable, TAS max, you can only have day time frequency or monthly time frequency. There's no hourly data. And everything above monthly, you can just calculate on your own. So let's go with monthly data and click search again. And then it will show you what models there's data for. So you've chosen this project, this variable at this time frequency. So now we're gonna choose the model. So these are all the different climate models, and they were developed by different agencies and research institutions and a lot of different countries too. So you can just choose one. Let's go with this one. Choose that model. And there you go. You have all these different data choices. And if you're gonna get data from a lot of different models, it's a good idea to get them all from the same ensemble, of course. And this is one I've used a lot. Oh, and another thing, actually, let's cross the ensemble out because it will self-select itself once we choose the experiment we're looking for. So you can also get historical model data here, but I was using projection data. So RCP is the different representative concentration pathways, I think it's what it's called. And it just, the different levels of radiative forcing in the atmosphere for different scenarios. So 2.6, 4.5, and 8.5. So climate is going to change depending on the concentration of greenhouse gases in the atmosphere, and you can choose that. So 2.6 is the lowest one, so let's go with that. And then now, it's been narrowed down to all of these. And if we go back to the ensemble, you can see that the list got a lot shorter. So let's say you decide to go with this ensemble for all your models. You want to be consistent. And then here is the data packet that you've chosen through these parameters. So this is the project, the model, the experiment time frequency, your variable, and the ensemble. And here you have the list of all the data you can get. And since we want a temperature, you can just search for that TASMAX. And as you can see, there's these two options. And how to read this is that's the variable in the temperature of the atmosphere for this model, this scenario, this ensemble, and then here is the year. So it starts from 2006, January of 2006. Remember, we chose monthly data. That's why there's no date here. And then goes all the way to the year 2100 December. And this model has data all the way to the year 2300 if you want it. But we'll stick with 2100. That's good enough for our purposes. And once you've chosen the data that you want, all you need to do is click on this HTTP download button. And this has actually happened to me quite a bit, but you can just go there and click on keep going. I accept the warning. And here you have to sign in again. And you can see that it's already started to download down here. So that will take a while. But keep in mind that all this climate projection model data comes as netcdf files. It's a type of file, and the way they do this is because it's a grid of data, so you have latitude and longitude and temperature over time. So it's this three-dimensional data that's saved as netcdf, as a netcdf file. And if you're unfamiliar with that type of file storage, I will put a link below on this article that a professor wrote that's helped me figure out how to open it. But I'll also make another tutorial later on showing what to do with this downloaded data right there, and how to visualize it in a way that makes sense, because we cannot read netcdf files without transforming it into a graphic or a map in some sort. So that's it for today. This is a little more confusing than downloading historical station data. So if you have any questions, feel free to put questions on the comment boxes below and I'll get to them later on. That's it. Thank you.